All right, we have a quiz coming up, 3.3 and 3.4. If you need help with the review, you're in the right place. I'll go over each of these questions, and you can fast forward through the video at any point to try and skip to the ones that you really need to know, or just watch the whole thing if you really have no clue what's going on. All right, identify the dependent and independent variables in each situation. Now, the cost of a dozen eggs depends on the size of the eggs. Okay, so it kind of tells you right there that the cost depends on the size of the eggs. So the cost is dependent upon the size of the eggs. So the dependent variable is clearly cost, since it depends upon something, and the independent variable here is the size of the eggs. Ooh, this is, again, hard to write vertically because my tablet is standing up, not laying down. Size of eggs. There we go. All right. So Allie works in a shop for $18 per hour. That's all we have. All right, dependent variable, independent variable. So there are two things that can change here, okay? $18 per hour is never going to change, right? $18 is always $18. The variables are things that change, right? Things that fluctuate, things that vary. Things that could vary are how many hours she works, right, per hour, but we know it's 18 per hour, but we don't know how many hours she'll work, right? And then the amount of money that Allie makes overall would change depending upon the hours that she works, right? So there are two things to consider: the number of hours that she's going to work and the amount of money she makes based on the number of hours she works. So since the amount of money she makes is dependent upon how many hours she works, the amount of money she makes is dependent, and the hours she works is independent. Another way of thinking about this is, what do you have control of, right? Whatever the independent variable is, something that you'll have control of that you can change that will affect something else. So here, Allie can change the number of hours she works, and in turn, that will affect the amount of money she's paid overall. So the independent variable is the hours she would work, because that's what she can control, that's what she can fluctuate, and depending on that will be the amount of money she makes. That will affect how much money she makes overall. So let's see, I guess money made, we'll just say that, right? Money made or money earned. All right, number 3, 5 pounds of apples cost $7.45. Again, the $7.45 is not a variable, right? A lot of times people see these numbers and they think, oh, math, numbers, I'm going to write that down somewhere. Maybe I'm going to get it right, but that's not the case at all. Variables, like I said, last problem, fluctuate. Things that vary, things that change. 7.45 is never going to change. So what does change? Well, the pounds that we buy, right? 5 pounds of apples cost $7.45, but I could buy more apples if I wanted to, so, or fewer apples. So the pounds of apples that I buy, I can change. I can affect that, right? So that is my independent variable, is my pounds that I buy, pounds of apples, right? I can control that. I can change that, and that can fluctuate. Now, depending on the pounds of apples that I buy will affect my total cost, right? Obviously, if I buy more apples, like, it'll cost more than $7.45. If I buy fewer, it might cost less. So, but the total cost. Okay, I apologize for the bad handwriting. It's just like, it's like writing on a screen here. That's technically what it is. It actually is a screen though, but it's standing up. It's not laying down, so it makes it harder. For each situation, identify the dependent and independent variables, just like we did, and then write a function in function notation and use the function to solve the problem. All right. So, a plumber charges $70 per hour plus $40 for the call. What does he charge for 4 hours of work? Okay. Remember the second sentence here, what does he charge for 4 hours of work, is solving the problem. That's our last part of the problem. It's like a part 2. We can do everything else in the first sentence, but that sentence is the only thing that's going to relate to the solution. So ignore that for now, and let's focus on dependent, independent variables and our function. And we can get all that information from just this first sentence. So plumber charges $70 per hour plus $40 for the call. So dependent and independent variable. Remember, independent variable is something that can change and fluctuate and affect something else. So the independent variable here would be the hours that our plumber works, right? Hours worked. Oh boy, let me try this again. Hours worked from our plumber, of course. And depending upon how many hours he works will affect the total charge of our plumber, right? The more he works, the more he charges. Think of it like that. So the more he works affects the amount that he will charge. So amount charged. Here you go. All right, now we need a function for the information that we were given. So a function, we're going to be writing this as f of x. You can write f of h, anything of that kind of nature. Is this not going to work? Oh, great. It's going to do that lag thing again. Okay. F of x equals there it goes. It works a little bit there. F of x equals, now he charges $70 per hour plus $40 for the call. So x represents the number of hours, right? So 70 times x, $70 per hour, plus the $40 for the call. So plus $40 for the call. So plus 40. All right, again, the pen's not working properly here, so it's a little laggy. And it makes it tough, but there it is. Okay, 70x plus 40. A plumber charges $70 per hour. That's 70 times x plus the $40 for the call. Now the solution. Now we actually go to that part 2, right? What does he charge for 4 hours of work? Well, to answer that, we would plug it in, right? X is number of hours, so plug in the 4 for x. So we do 70 times 4. Get that number, then add 40 to it. 70 times 4 is 280 plus 40 is 320, I believe. I'll let you guys double check that. But yeah, you just plug it in to your function and solve. So number 5, a sanitation company charges $4 per bag for garbage pickup plus a $10 weekly fee. A restaurant has 14 bags of G garbage. Okay. What will the sanitation company charge the restaurant? All right. I was confused there for a second why I said 14 bags of G garbage, because G is the variable that represents the number of bags of garbage, but then they already told you it was 14 bags of garbage, so I got kind of confused. But I think I get what they're saying. But let's focus first on our dependent and independent variables. So a sanitation company charges $4 per bag for a garbage pickup plus $10 weekly fee. Okay, so we should be able to identify the independent and dependent variables from our first sentence. So independent variable is something that we can control. For example, the number of bags, right? The number of bags would affect what? The number of bags independent, and it affects the total charge from our sanitation company. So independent will be bags of garbage and dependent will be what that affects. The more bags of garbage, the more the company charges. So the bags of garbage affects the total charges, right? Company charges. How much they charge us, basically. How much money we would have to pay. All right, our function can also be given from that first sentence. So our function is going to be g, by the way, because notice they're giving you the variable g. So we're going to actually have to use a function of g, f of g, rather than f of x, g for garbage here. And we're charged $4 per bag. So that's saying 4 times g, plus a $10 weekly fee. So plus $10. There you go. Now we find our solution, right? The solution for the question that's being asked. A restaurant has 14 bags of G garbage. So that's literally telling you that you're looking for plugging in 14 and getting a result there. So if you have 14 bags of garbage, you'll have 4 times that 14 bags of garbage plus the $10 weekly fee. Again, I'll let you guys do the calculation on that because I don't have the calculator here. I don't want to get that wrong. A bakery has prepared 320 ounces of bread dough. A machine will cut the dough into 5-ounce sections and bake each section into a loaf. Write a function, f of m, to describe the amount of dough left after m minutes. How many minutes will it take the machine to use all the dough? Find the reasonable domain and range for this situation. Okay. So, let's follow the instructions. We are first asked to write a function f of m. So we're going to write a function f of m equals. Now our function relates to the fact that we have 320 ounces of bread dough, and we are using 5 ounces at a time, right? So what we have this is kind of backwards from how normal problems we've done, because in this case, we actually have a total and we're taking away from that total, right? We have 320 ounces to start with, and then we're taking away 5 ounces at a time. So our function is going to be 320 minus 5m. So what that says is we we start with 320, and then for every minute that passes, we lose a 5-ounce section. So we're subtracting the 5m from it because our total will be going down, right? We start at 320, but we'll be subtracting from it because we continue to cut dough out of that amount. So there's your function. Now, how many minutes will it take the machine to use up all the dough? Okay, so now to do this, remember f of m represents the total amount of dough that's left, right? M represents just the minutes that are passing. So this question here, how many minutes will it take the machine to use all the dough? That's referring to having 0 dough remaining. So it's saying that our solution, our answer would be 0 dough remaining, 320 minus 5m. Essentially, we have to figure out, 320 minus 320 would be 0. So we have to figure out what makes 5m 320, if that makes sense. You could solve it using like a regular function like this, where you add 5m to the other side, right? You have 5m equals 320, right? Then divide by 5, and whatever that is, it's going to be like m equals, let's see here, 64 maybe, I think. I'll let you guys figure that out. I think maybe 64, but double check that. Okay. But yeah, we're essentially asked, okay, so if you want to think of it this way, remember we have 320 ounces to start with, and we lose 5 every minute. And if we use up all the dough, then we use up all 320. So basically, we would have 320, and then our goal is to figure out how many minutes have passed by until 5m becomes 320 ounces, right? Because 320 minus 320 would mean that we have 0 dough remaining. So that's why, 5m ends up equaling 320, and why we solve that, because we're trying to figure out what makes or when this equals 520. How many minutes will it take until 5 ounces becomes 320 ounces? And so that's why we do that. But in a sense, you're really just setting this equal to 0 and then solving for m. So you could do what we did the first time. You could do it this way. You could subtract 320 like this, and you could have negative 320 equal to negative 5m. Divide by negative 5, and you get the same result no matter what, but I just kind of wanted to explain it through a more logical point of view, from a more common sense approach rather than like an algebra approach. Okay, so you'll have your answer. I think it was 64, but again, do your calculator because I'm not 100% sure. I'm pretty sure though, but you can double check. But find the reasonable domain and range. That's kind of the part that I really want to focus on here. Domain and range. So domain is reasonable x values that we could plug in. Now in this case, we're talking about time. So really our domain can be any amount of time. Now, I will say that this domain is dependent upon the answer you got in the last part, where we had the minutes was 64 minutes, I believe. Because our domain is about minutes, right? Our x values are our minutes. So we could have 0 minutes, essentially, right? Because then at 0 minutes, we know we could plug that in. We would have 320 ounces of dough. But our max, we can't just go on forever because at some point we run out of dough, right? At some point we run out of dough, and that's what we just found out in the previous question, which I believe was 64, right? If it takes 64 minutes to run out of dough, then that's our maximum amount of time. That's our maximum number of minutes, right? So our minutes can be anywhere from 0, which is starting time, all the way up to 64, assuming that that's correct again, because that was how long it would take for all the dough to run out. And then our range, well, remember we have 320 as a max, and we can only go all the way down to 0 ounces of dough. So we're going from 320 to 0, but we can't write that backwards. We're going to write from 0 to, I guess I'll write y here, to 320. This is just saying the amount of dough that we could have. The range is the amount of dough. And we could have anywhere between 0 ounces remaining or 320 ounces where we started with. So our range would go from 0 to 320. And then again, our domain was the number of minutes used. And it's very important that you understand that that number here is dependent upon the solution to the equation that we were doing earlier with when we eventually had 5m equaling 320 and we solved it. I said m was 64. I'm pretty sure that's right. But I'll let you guys verify. All right. So that number depends on that because that's the maximum number of time that we could use, right? After 64 minutes, there's no more dough left and there's nothing else to do. So 64 minutes would be the cap. All right. So 3.3, 3.4. Now we're going to graph, okay? Complete the table and graph the function for the given domain. So in 7 and 8 and 9, sort of, it gives us a domain to plug in, right? It gives us -3, 1, and 5 as our x values to input into our function and get y values out for. So we're just going to follow those instructions. Our function in number 7 is 3x minus 2, but we're going to be plugging in first -3. So we're going to have 3 times -3 minus 2. And 3 times -3 makes -9, and -9 minus 2 ultimately becomes -11. So that's 1 point for us that we'll have to graph. Now let's plug in the next x value, which is 1, right? 3 times 1 is going to be 3, and then 3 minus 2 makes 1, so that'll be the point 1, 1. And then one more, we have to plug in 5. So when we plug in 5, 3 times 5 makes 15. 15 minus 2 makes 13. And so I've found all my y values, all my output values for each input value. Now I'm just going to graph those 3 points. -3, -11. Now, what are these? These look like they're going by 2. So -3 is going to be halfway between the 2 and the 4 here. If you want to label them, let's zoom in a little bit. So keep in mind, these are going by 2. 2, 4, 6, 8. These are all negatives, by the way. So -3 is going to be right between -2 and -4. And we're going down to -11, which will be right after -10. So it'll be about right here. Okay? If it helps to label these, then I recommend you do that. So 2, 4, 6, 8, 10, 12, etc. 2, 4, 6, 8, 10, 12, -2, -4, -6, -8, -12. Right? So you can do all that. If that helps you keep count a little bit. The next point, we got to leave this one there. There we go. The next point was 1, 1, which would be right here. And then 5, 13. 5 would be right there. 13 would be way up here. There you go. And that is it. That is our answer. We do not draw a line here. Our domain was limited to only those 3 points. So we are only graphing those 3 points. No line. Okay, our domain is restricted to only those points. It's discrete, not continuous. Okay, now number 8, a little fancier because we don't have a function where y is really by itself yet. We know we're plugging in these numbers for x. However, it's not as simple as the first problem where we had, y equals or f of x equals already. So what I'm going to do first, we have y plus 2x equals 12, is I'm going to try and get the y by itself. Now, in order for me to do that, I got to move this 2x to that other side. Now, to cancel 2x out, I'll have to subtract 2x because, notice what happens here. 2x minus 2x is Well, 0, right? So that's going to be y plus 0, or just y, equal to, now because I subtracted 2x on the left, I have to subtract 2x on the right to keep everything balanced. So now I have the negative 2x plus 12 on this side. You could write 12 minus 2x. It's not going to be any different. It'll work out exactly the same for us. I just get in the good habit of writing the x term first. So it's a minus 2x, so I write negative 2x. And it's a positive 12, so I write plus 12. Well, that's a good function for us to plug into now. So we're going to plug in the numbers 2, 3, and 4 into this function. So we have negative 2 times, we'll plug in 2. Well, actually, let's write the function out first, and then we'll plug it in. So negative 2 times 2 plus 12. This is going to be negative 4 plus 12, which is 8. All right, let's plug in another one. So we plug in 3 next. Negative 2 times 3 would be negative 6 plus 12, which is positive 6. And then we'll plug in 4. Negative 2 times 4 is negative 8. Negative 8 plus 12 is 4. All right, so there we go. We are good to graph these now. And we're only graphing those points because remember our domain is discrete. It's only at 2, 3, and 4. So 2, 8 will be, this one's pretty easy to graph. 2, 8 right there. 3, 6 right here. And then 4, 4 right there. And it's just those points, no lines. Okay, and then number 9. Number 9 is a lot trickier, so I imagine a lot of people might have just fast forwarded to this part. But 3x minus 3y equals 9. Now, if you just fast forwarded to this part and you missed number 8, what I'm about to do here is something similar I did in number 8, which is solve for y. I'm going to try and get this y by itself. So I'm going to try and find a way to get rid of the 3x and this negative 3, because if both those things are gone, then the y is going to be the only thing left over. Now for me to do that, I have to take care of the x term first, because this negative 3 is attached to y. I have to save it for last. So I'm going to get rid of the 3x term first. Now I'm going to do it the same way I got rid of the 2x in the previous problem, which is subtract it. Because what happens, 3x minus 3x means 0 x's, means nothing left is there. Those will cancel out completely, becoming 0, leaving you with just minus 3y. But since I subtracted 3x on the left, I have to subtract 3x on the right as well. So that leaves me negative 3x plus 9. It's the same thing as 9 minus 3x, but I like to get in the habit of writing the x term first. So it is a negative 3x, so I have a minus 3x, and then it's a positive 9, so I had the plus 9. All right, so now I'm going to get rid of this negative 3. It's very tempting to add 3 here, because you see the minus sign, you think, okay, the opposite of minus 3 is adding 3. You're not wrong, but you are reading it wrong. That negative 3 is being multiplied to y. So it's attached to that term. So in order to get rid of it, because it's being attached to that term, not being subtracted or added to it, it's actually a part of it, is you have to divide. Now the reason for that is because negative 3 divided by negative 3 becomes positive 1, not 0. And that's what we want, because we don't want 0y. We just want 1y. We want just regular old-fashioned y. So dividing by negative 3 turns that negative 3 now into 1, because negative 3 divided by negative 3 turns into 1, giving our y just 1y, letting it be by itself. But because I divided that by negative 3, I have to divide everything else by negative 3 as well. So you'll see negative 3 divided by negative 3 is also going to create a 1x. You can write 1x, or you can just write x. It's the same thing. And then 9 divided by negative 3 is negative 3. So there's our function. We have y equals x minus 3. Okay, so you'll notice that the domain was given to us as 0 to 8. So if these numbers weren't here, we would just plug in any numbers we want from 0 to 8. We can plug 0, 1, 2, 3, 4, 5, whatever. They've already picked 0, 3, and 8 for us to plug in, but keep in mind what our domain is, because that's going to affect what our graph looks like. But we'll go ahead and we'll use the values that they gave us. We'll plug them in, right? So we'll have y equals, we'll plug 0 in. 0 minus 3 is going to be negative 3. All right, if we plug in 3, 3 minus 3 is going to be 0, so negative 3 is going to be 0, or 3, 0. And then we're plugging in 8, and 8 minus 3 is going to be 5. So there are those points. We're going to plot those points. 0, negative 3 is right here. 3, 0 is right here. And 8, 5 would be right here. I would really recommend we hit more points on here than that because it's not a very good graph. So, for example, if I plugged in, let's say 1. If I plugged in 1, I would have 1 minus 3 would be negative 2, so 1, negative 2. If I plugged in 2, 2 minus 3 would be negative 1, so 2, negative 1, right? It helps to have more points so that you can get a better idea of what the graph looks like. If we plug in 4, 4 minus 3 is going to be 1, so 4, 1, right? You can really start to see that this is going to take the shape of a straight line. If you plugged in 5, 5 minus 3 would be 2, and so you'd have 5, 2. And you can really start to see that line. Now, here's where this domain comes in to be really important. The domain is from 0 to 8 continuous. So it starts at 0, which is at this point here, and it ends at 8, which is this point here. But it's continuous between those points. So that means that all the points that we have between them would be connected with a line because it's continuous on those points. It's not just those points. It's not just 0, 3, 8. Because if it was, then it would say up here, it would say 0, 3, 8 instead of what it says. But it says 0 to 8. It says it's continuous from 0 to 8. So between this 0 point and this 8 point, you would have a line connecting them. There's no arrows or anything at the end. It's just there to there with a line connecting them. I only plotted a few extra points because I wanted to make sure that my line was straight. That wasn't necessary, but it helped because it showed me a little bit more of that line. It made me see that it was straight a little bit better. So it doesn't hurt to always have more points, especially when your graph is continuous. You're allowed to plug in those points. I wouldn't be able to do that on something like number 8 or number 7 because on number 8 and number 7, I was only told to use these 3 values, right? But the difference in number 9 is it didn't tell me 3 values to use. Technically, I'm allowed to use anything between 0 and 8. They just gave me 0, 3, and 8 to start with for some reason, but we are technically allowed to plug in any number we want from 0 to 8, which is what I did so that I could see the line a little bit better and then graph my line. Okay. And yes, this one's continuous from 0 to 8, which is why it's a line. And these were only discrete points, so that's why it was only those 3 points on that graph and 3 points on that graph. Hoping to clarify a little bit of confusion for you there, because they are very similar, but they can be kind of wishy-washy, That's going to be it for this review, guys. I hope it helped. I will see you tomorrow for your quiz. Bye.